Everyone, welcome back to the channel. You're watching yet another video on infrastructure automation testing with Terraform and Azure resources. This time we are going to talk about Azure SQL Server as the infrastructure resource and how do we automate the testing of Azure SQL Server with Terraform and TerraTest. So this is the repository which I'll be using for the demonstration. And this time we are going to talk about this module which is available here in my repository. The source code is available to you, which you can find it in this particular link. I'll be sharing the link in the description for your reference. So before I start talking about the demonstration or the actual test case, let's understand what are the different scenarios or the steps we are going to have with the help of this sequence flow diagram. So to start with it, the very first thing we are going to have is we are going to define the list of variable, constant, parameters, and then we need to import certain number of packages like system packages or some of the TerraTest or built-in Azure resource manager packages. Next thing, you are going to have a method to set up the Terraform execution. For example, how your Terraform execution should run from a Go language. Apart from this, you need to also have a method to set up a login mechanism for running your Terraform, and also a logging mechanism to use the Azure SDK Go language package so that you can make use of Azure REST API to get the data of your resource to compare with it. So that is what we are going to do with the setup method. So there will be a setup method which I'll walk you through. Once these two methods are there, like I said, you are going to have the initialize, plan, and destroy, which will be running, and after it runs, you check whether the Terraform apply has succeeded or not. If it is not succeeded, your test case is going to be marked to fail. If it is succeeded, then your code is going to call the Azure REST API get by ID, which is get a resource by resource ID. So it will get the detail of a particular resource. It will return a JSON if a resource found, which obviously it is going to find because we have just now created with our code. If it is not found, then it will simply run the destroy command, which is it will destroy the resource. If it is found, then finally we are going to have a method or a block of code basically which will perform the assertion using the assert package, right? So we are going to import the assert package, and that will basically run the assert, and once the asserts are going to run, it will finally destroy the resource so that we are not hanging the resource floated here and there in the Azure subscription which are being generated from this particular code. And once that activity is done, your test case is going to be marked completed, right? So this is the overall flow of the code or the test case which is going to be there, and that is something I'm going to walk you through how it has been written, and you can understand from the GitHub repository as well. So this is the Visual Studio instance where I have opened the same repository, and as I said, we are talking about the SQL Server module, and we would like to automate the testing of the SQL Server module. So this is the module I have right now, and in this module I have the simple code to provision the SQL Server, and this is what the resource block I am using. Now to define the SQL Server, I am using a couple of variables like the name of the SQL Server, resource group, location, version, SQL Server administrator, login, and password, right? All these variables are defined under the variables.tf, nothing too complicated. So if you understand the Terraform, you would understand that you have to define these variables in a variable file. Now once the resource is going to be provisioned, we would like to generate an outcome from that resource, and that too I have defined inside the output.tf file. Now one thing to remember here, I have used the providers block in my module because in order to run your test cases or run this particular directory as module from your test cases, you need to have this providers block inside your module file, right? Any of your module files, you can create a separate file or you can add it inside the main.tf file as well. With that, our code is ready. Having this code in place, I should be able to generate or provision a SQL Server in any of my Azure subscription, right? Now to define the test cases, as I said, we are going to use the Terratest, which is developed on top of Golang. So which means that you need to have a bit of understanding of the Golang. I'm also not super familiar with the Go language itself, but I have tried and learned the Go language, whichever, like I have tried and learned the part of the Go language so that I can write these kind of a test cases for my Terraform infrastructure and I can automate it. So I'm going to walk you through the same. So what I have done here under the test folder, which is defined inside my module itself. So in my SQL Server module, I have this test directory, and inside this test directory, I have defined this main_test.go. Remember that the name of the file should have the test as in keyword. The reason for that is when you are going to run the Go language command, like you run the Terraform command, when you are going to run the Go language command or the test command in the Go language, it will figure out the test cases based upon this file name as well. Now, apart from this, I have another file which is a response type.go, and that I have created to define my custom type or the custom type for my outcome, which I'll show you later, but remember that this is the additional file which I have created. Now if I open this file, the very first line we have is the package name, like inside this main_test. So you have the package name. You can call this particular package name anything. I have given a name as in main. Again, if I open the next file, which is a response type, here also I have defined the package name. So think like a package name as a namespace in your .NET language. So in order to make any of these structure compatible with each other on the different files, you need to define the package name as in same, right? So make sure that your package name is main. If you define main, then you have to define the main here as well, right? That is what at least I have understood. Maybe there are some different technical reason for that, but like I said, I'm not fully proficient on the Go language. But if you remove this package name or rename to something else, your test case are going to start it failing because it will not understand the type which you have defined in the response type.go file. Next, you have the imports block. So what imports block is, basically you are asking your Terraform or you are asking your Go language commands to download these references or the libraries inside your code when the codes or the Go language codes are going to run the test command. So these are some references or libraries which we are trying to import inside this particular code block. So some of these which you see at the top, like context, encoding, format, FMT, log, OS, reflect, string, these are the system type, like it's defined by the Go language itself is the system libraries. That is why you do not specify any other languages or any other namespace before that. But the namespace or the packages which are like Azure SDK for Go, which means there is a SDK for Go language which has been created or maintained by Microsoft Azure community, that has been defined onto a GitHub repository, and that is why the URL starts from, or the name starts from github.com/Azure/Azure SDK, which is the name of the package, and then you have the further namings like SDK/identity. So these are some kind of a custom managed package which are managed by individual users or community of user. In this case, these first two packages are managed by Azure community users or contributors, and then next two packages are packages related to the Terratest. So make sure that you have these packages as well, because these are some packages which we are using. Any of the package which you add it here in the import section, but if you are not using any of the content or the syntax of this package inside your code, then your Terraform will, then your Go language commands will complain about it. So unless if you are not using it, you need to remove that. Anyways, it will give you an error and you will get to know that it is getting error because of something is not being reflected or not being used, right? Moving on, you have the constants. So we are declaring certain number of constants, in fact two constants. First constant which is being decorated with a constant and then opening small bracket, closing small bracket, and inside that we have two constants. The first constant is defining my source code directory location. So directory location is one level up. So if I am in this inside this test directory, one level up is going to be my SQL Server directory, which is my module. That is where my module is. So this is locating the directory where my source code is, which will be using this constant later in the source code. Next, you have the API version. Now, why API version? Because we would like to validate our result against the actual resource which is being provisioned by Terraform. So, and to validate that, I'm going to use the Azure REST APIs, and which version of REST API we are going to use, that is what we have mentioned here as in constant value. If you might have referred my previous videos on this Terraform testing where I have discussed about the resource group, key vault or storage account, I was comparing my, or I was writing my assert with the help of the output. But this time I'm not going to use the output to compare the actual versus expected, or I'm not going to use the output for writing my assert. I'll be using the actual Terraform or actual Azure infrastructure outcome, and I will compare the actual values which is being provisioned at the live subscription with my expected values. The reason for that is because let's say if you have mentioned expected name as this, right? And if you are trying to compare with the expected versus output, and if I somehow hard code the value of the output with the same value, my test cases are always going to be passed, no matter whether the resources are actually provisioned or not, because you have mentioned you have hard coded the value in the outcome, and that is something you do not want, right? And that's why I decided to use the REST API so that I read the content or the actual resource description or resource property from the Microsoft Azure using the REST API, and that too I will be using in the asserts by comparing actual versus expected. And that is why this particular demonstration is totally unique and it is different from my previous videos, so please pay attention to that. Next, you have the variable files, and inside the variable files I am trying to declare certain number of variables. For an example, if you have any backend configuration file, you can define the backend configuration file like this, or at least the variables are declared like this. Next, I have declared some unique postfix. So basically these three variables I'm not using it at the moment, but next three, which is expected name of the SQL Server, location in which it should be deployed, and the resource group, which is the existing resource group I'll be using, right? Next, I have the subscription ID, which is defined as a standalone variable. This is just to show you that you can declare the variables with two different types. Here, the grouping of variable, and this is where the individual variables are being declared, right? Next, we have the method. So we have created a function. For function name is set Terraform variables, and this is what the variable input arguments are. So it's going to map of a string, then array. And what we are doing here is we are reading some of the environment variables. So what environment variables? So environment variables like Azure client ID, secret, tenant ID, subscription ID, and that too we are going to first of all set as an environment variable onto a Windows command line. I'll show you that in the demonstration. And next, we are, after reading it, we are setting those variable into an environment global variable, right? And that is so that it can be used it afterwards. So this method is going to have a return type. It's going to return this global environment variable, right? Next, I have defined a custom type, and the type name is test condition, which is of type integer. And using this custom type, I have defined some constants. So my constants are test conditions equal, test condition empty, test condition contains. Basically, it's way of defining the enumeration with Go language. That is how I compare with this code along with my .NET application code, right? It may be again a different reason, but this is how I read it. Next, I have another function which is basically for Terraform options, and what with that Terraform option what we are saying is, if you run the Terraform code and this Terraform is using this Terraform module, which is this one, right? So the reference has come from this module. So this module says from this option, this is when the Terraform commands are going to be run with the help of this module. The directory is going to be defined with the help of this variable. Variable file is defined with the help of this. map file is defined, or the individual variables are defined with this. Now here if you look at, I have used both variable files as well as var. So it is up to you which one you want to use it. Do you want to use test and like variable files in your Terraform command, like Terraform plan dash var file is this, or you want to use dash var individual variable names like this, or you want to use both? Like in this case I've used both of them. At the moment my variable files is going to be, I can make this empty if I want to, like this, right? And let's talk about the next thing. So this is my variable files. There are some other options as well which you can configure it, but at the moment those are commented out. And now next method which we have is the test method. So test method name is test underscore automation, and then it is taking pointer to a function argument which is of type testing. It is coming from testing module, which is again coming from the main central package library. Now inside this test method, first of all, before I talk about the method body itself or method description itself, here the name of method must have a test keyword. It may not be an underscore, is not needed, but at least this test keyword is there, because when you are going to run the Terraform, or when you are going to run the Go language test command line, then it will look for any method which is having the name as a test as a prefix, and then it will treat that method as a test method and it will execute that. Now inside the method we are calling the set Terraform variable method, which is this particular method, which to set our global variables and all, or read the environment variable. Next we are saying that using the Terraform module or Terraform import block, it should configure, it should run the init and apply, and then once it runs the init and apply, it needed to run the destroy command, and to run the destroy command it is marked as a defer, so that it always run the destroy command no matter your test cases are pass or fail. Even though if your asserts are going to fail, it will still run the destroy command, so that your infrastructure always gets destroyed regardless of your output, right? Now once after this line of code, what we are saying here is at line number 98 I am trying to read an output of my Terraform resource provisioning, and what I'm trying to do is I'm trying to read the ID, which is a resource ID of my resource which I'm trying to provision. So in this case it will return the resource ID of the SQL server. Now using this resource ID, what I'm trying to do is I'm trying to make a call to a function. The function name is get resource from REST API. I'm passing the resource ID and I'm also passing the subscription. Now where is this subscription coming from? This subscription is actually defined as in this particular from this method, and it's coming from the environment variable, right? Now I'm taking the output from this method as a response data as well as error, and the response data itself is something which I'll be using it later on, which I'll show you in my assert. As of now I have not defined any assert as such, but I'll be defining that assert and I'll tell you how to define that after this line of code. Now let's take a look at the body of this method, which is this particular method. Here it is taking the resource ID and Azure subscription as a string type, and it is going to return the response base and array and error if in case if there are error. Now you might ask, what is this response base? So this response base is a specific custom type which we have defined here in this particular file. So this is my response base structure, and the body of this response base is looks like this: resource, kind, location, name, property. Property itself is a type of complex type, which is a property which has these many attributes. Now you may ask question that how you know that this is what the structure should look like. Well, I'll give you a reason, or I will give you a way to know what kind of a structure your response type should look like. So let me just go to the file, which is this one. Now we'll read again. So what I'm trying to do is I'm using the Azure identity package, and with that I'm using the Azure resources class or Azure resources instance, and from here I'm making an instance of a client or the Azure client using the method new client, and I'm passing the subscription ID and the credential. Now remember, this credential is being gathered with the help of this method, which is a new default credential, and this default credential actually will collect the or make use of the environment variable which we have set up. Now, to know better how it is working, what you can do is you can go to the definition, or you can open this particular URL on your browser, and you will get to know how it is trying to use the default credential, or to set the default credential using new default credential, and to use the environment variables which we are going to set. Now once your credentials are set, we are going to call the new client to generate a value of new client. Once you have the client, you are going to call get by ID method. So it's going to make a call to get resource by ID, REST API call, and here we are going to pass the resource ID, which is the resource ID which we have received as an output of our resource from the Terraform output, and then API version, which is the version of API which we have defined. Remember that this API version, you have to know that this is what the API version supported for this specific resource. It may possible different resources are having the different API version supported, so the value may differ depending upon the resource you are trying to provision. Next, you have the resource which you are or the output response which you are collecting as a response of get by ID. It's going to be a JSON response which is going to be of string type. So what we are trying to get it here is I'm trying to first of all trying to typecast this response. So I'm using the system reflect class and using the type of, and then that way it will give me the type of value for the data type value for this particular response which I'm receiving it, just to know the data type, nothing else. Now as I'm going to have the data type, I'm going to just generate the ID, which is a resource ID, and the name, and that is what I'm going to print here. Now why I'm printing it? Just to make sure that I'm getting a proper response and nothing else. Next, I'm trying to do the serialization and deserialization, so that I would basically typecast the value which I am receiving from the get by ID function to this specific type which I have declared. Now as this resource type is going to be of a specific type, so what I am doing with the json.marshall file, I am trying to convert the object into a string type, which is I'm trying to serialize this object with a string type, and this is my serialized output which I am printing it here. Now why I am printing this value here? So that I will get an idea of the structure of a JSON which is going to be returned from this output. Once I have the idea of the structure, which in this case of SQL is going to be look like this. So this is going to be your output, and in your output you would have, let's say, ID, location, kind, name, and then property which is of type object, which will have these many attributes, and then tags and output. Having the idea of this JSON, I can define the structure of my class. So now if you look at this JSON which has been returned by the SQL, I can generate or can define my response type. So response type is response based, and I have defined the same thing. Resource ID, the JSON, in the JSON the name it's going to be ID with a small I, small d. Kind, it's going to be small starting from kind, and which data type is obviously going to be string. This way I've defined the structure by looking at the JSON which is being returned, and I've typecasted this JSON into a data type which is of type, basically I've typecasted into a serialized into a string, right? Once it is serialized, what I'm trying to do is I'm trying to convert the string into a byte, and then from that byte I'm unmarshalling it using the JSON package, and basically I'm converting this bytes into a response type. It will be easily converted because the structure of the response type which I have created is exactly the same as what is given here in the JSON, right? If it is not, then whichever property is not mapping or not matching, it will be ignored, right? Having this code in place, now the things come is basically how do you run that code. Now the very first thing you need to run the code is you need to set up the environment variable, right? Now how do you set up the environment variable? So what I have done is I have to set up, first of all, let's say open the command window. So I'll right click on this particular file, I'll open the terminal, and then I will run the environment variable set command. So the command is going to be $env colon and then the name of your variable. So variable name we need is Azure underscore client ID equals to the value of the variable. Now once I'm going to set this variable value, it will be used, remember, in our set variable operation. So that is the operation name, set Terraform variables. It's going to read the same variable from the get environment, os.get environment. That is why we are using the os package, right? So let me just run this command and that will set the environment variable. Next thing we need is we need to have the environment subscription ID, Azure subscription ID. So it's going to be the same thing, env and then name of your variable, which is Azure underscore subscription underscore ID. Next command you need to run for the client ID, and then finally you need to run the value for the secret. We are ready for the test. So to run the test, the command which you need to run is go init. So this is the command you need to run, go mod init, and then you need to give it the name of your module. You can give it anything. I have given a name as in test module. Then I'm running the same next command. So I'm appending the next command with double end sign, and then I'm running go mod tidy. So with a single line I'm running two different commands, one after other. So with the help of go mod initialize, it has created a new file. You can see that here a new file has been created, go.mod, and that is what the file name is created. Now it's trying to run the go mod tidy command. So what it will do is it will try and import all the modules or the block or the packages which we have mentioned to import it here in the import section. It will try and import. So it might take a time to import all those packages. You can also check in the go mode file in your source code if you want to, because I've seen Microsoft Azure package library, they have also checked in the code. So it's not bad idea actually. So that next time it will use the same mod file and it won't take a lot of time to download the packages. I'm going to pause the video so that it will download all the packages. So the command is run successfully. The next command now we have to run is the go test command dash the timeout value. The 30 minutes is the timeout I would like to give, and then dash v, so that it figure out the test which we have written, like assert. Though at the moment I have not defined any assert, if you would have paid the attention. So having this run in place, what I'm trying to do is I'm trying to just make sure that with the code I'm able to log on to the Azure subscription, log on to the Azure API call, basically provision the resource, get the data, and then after that I would like to destroy the resource. That is what I want to test it. And then afterward I will place the code which can perform the assertion. So the assertion code is going to be the same code what we used to see earlier, right? And this too, it's going to take a couple of minutes of time on my local machine because my local machine performance is not too super fast. Terraform initialization is successfully completed, as you can see from here. That's the initialization block which has been completed. Next, it's trying to run the Terraform apply command. So that's the apply command block which is started from here, so that it's going to be provision the resource which we are looking for. So now the resources are also trying to provision, as you can see from this plan. It's trying to provision the resources. The resource deployment is successfully completed, and we have got now one resource completed. It has also generated the output which it's going to use to compare or to run the test cases. Here, after provisioning the resources, we are able to get the output in the JSON format like we discussed in our theory, and this is the outcome. So what you can do is you can simply copy this outcome like this. You can go to the JSON lint and you can simply validate the outcome like this, and based on this outcome you can define your response type. So let's say these are some outer layer properties, 4 properties. Again, this is another outer layer property. This is a complex object which is of type property, the name of the object, and then within this object you have these many properties. So what I have done is, while it is running, I'll show you again. In the response type, I have declared the class or the structure name, response base. I've added those properties which has those attributes, and this attribute which is of type property itself, which is defined here, and you can see that this is what the list of attribute it has got. It's the same as what we have there in the code. The reason for that is, like I mentioned, we are going to typecast it to the serialize into a string and then deserialize back into the object, and so that when we are going to write our assert, we are going to use this object instead of using the individual attributes as in a string type, and I'll show you that how do we use that. So the final part of the configuration is adding the assert. So as you can see that here are the assert which I've added inside the same method, which is a test automation. It is just after the response you receive from the get resource from the REST API method, and using this response I'm going to make use of the assert, which is comparing the actual versus expected. And to compare that, what we have done is we have created a structure, a new structure type, and in that structure type we have got 4 different attributes. The attribute name, the name of your test case got, which is your actual response which you got, and then want is the name of attribute, which is going to be the expected attribute which you are looking for, and then the condition, which is of type test condition. Remember, this test condition we have declared as in data type, a specific type at the top. So using these 4 attributes, we have a structure which is of type array. So there is a variable declared test cases which is of type array of structure type, right? And to initialize this array, we have added these many test cases. So basically these are our test cases. So our first test case is, let's say, checking our resource name. So we are trying to compare the resource name with a resource name what we have tried to pass on as a parameter while creating the resource from the Terraform, versus the resource name which we have received as in get API call as a response. So this is our response from the get API call, and then response.name, I'm trying to basically get the name, and here we are comparing resource name expected versus actual. So basically we are just creating an element of this array, which is this one, this particular row. So it has got name, which is this one. It has got the parameter, which is the next parameter, what is your actual response you got, and then expected response which you want to check, and what condition you want to check. Similarly, we have remaining 3 other cases where we are checking the resource location, fkdn resource name, matching condition, and there are the contains condition also checking. Now, having this array of structure in place, what we are trying to do here is, next we are trying to add a for loop on this array, and for each element in the array, which is your test cases, for each test case we are checking what is the condition you have specified for each test case. For example, my first condition is test condition equal, second condition is test condition equal, third condition is test condition contains, and then fourth condition again is equal. Now based on this condition we have these 3 switch cases. So depending upon the condition, it will go and perform this particular operation, which is assert.equal, assert not empty, and contains. You can add many other cases and prepare other condition as well. It just you have to use this test condition type which is defined here. You can add those enumeration values like this here, and then make use of those conditions while writing the test cases, and of course you need to add the switch case as well. So having this case in place, in a summary, we are trying to basically get the data from the actual live resource which we have just now deployed from the Terraform, and then comparing the attributes of that deployed resource versus the attribute which you have provided while provisioning the resource, and checking whether the actual versus expected is matching or not with the help of assertion and with this data case. And with that, if I have run the test case, as you can see that this is the test case I have run, and what happens here is, first it has basically created the output, it has created a SQL Server instance, then it has got the output which we have received, and after that we are making call to the get API call. We got this response, and this is what we have printed as well, which is JSON response. This is just for one time. After that, you want, you can comment this write output, because once you get this output and you create your attribute or the response type, you don't need that. And after that, you are having all your test cases which are running here, and finally once the test cases are run successfully, whether it is pass or fail, it is a different thing. Your test case or your configuration, Terraform configuration, the Go language test execution will destroy the resources. As you can see that one resource is destroyed here, and you will have a result displayed here, which is, you can see that it has successfully completed, though in my local machine it took a lot of time to execute, but that is okay. At least you are able to run the test case end to end and comparing with the live run. Okay, that is it in this video. I hope you have found this useful. As I mentioned, you can find this repository code, entire code for all my modules like SQL Server, Key Vault, Storage Account, or any others which I'll be creating. You can find everything here in this particular repository, which is there in the GitHub. Link is provided in the description. You can simply download this code and run it on your machine or on from your pipeline, and you would be able to impress your client by having this automated test case with your Terraform code. If you find it useful, please do consider subscribing to this channel, and do not forget to click on the bell icon so that you do not miss the notification for the other resource or the other test cases which I'll be publishing for the other different Azure resources.